Today we will talk about D-Threonine production using Phylomicrobium marinum D-Threonine aldolase. We'll describe about diastereoselectivity of D-Threonine aldolase from Phylomicrobium marinum for the production of D-Threonine from glycine and acetaldehyde. D-Threonine aldolase is an enzyme that catalyzes the reversible conversion of glycine and aldehyde into beta-hydroxy alpha-D amino acids. This version is isolated from Phylomicrobium marinum, shortly abbreviated as FMDTA, has been studied because it shows higher activity and better stereoselectivity compared to other DTAs. D-Threonine aldolase is a pyridoxal phosphate PLP-dependent enzyme that catalyzes a reversible aldol reaction. The reaction involves the condensation of glycine and acetaldehyde to form either D-threonine or D-allothreonine or both, depending on stereochemistry. Reaction overview. Forward reaction is the aldol addition, aldol condensation. Glycine plus acetaldehyde gives to D-threonine or D-allothreonine or both. Reversible reaction, retroaldol cleavage gives D-threonine or D-allothreonine from to glycine plus acetaldehyde. Key features. This enzyme is PLP dependent aldolase. Products. Two stereoisomers can be formed. One is D-threonine, other is D-allothreonine. D-threonine is 2s3r configuration in, and D-allothreonine is having 2s3s configuration. It triggers several metal ions as cofactors. Among them, manganese is the best one. It requires pyridoxal phosphate and is activated by divalent cations like cobalt, nickel, manganese, and or magnesium. Reaction mechanism. Pyridoxal phosphate forms a Schiff's base with glycine. Acetaldehyde is added to the glycine PLP complex. Depending on the stereochemical orientation, either D-threonine or D-allothreonine or both are produced. Biological role. It is used in biocatalysis for the stereoselective synthesis of beta-hydroxy alpha amino acids. Aldol reaction condition. In this aldol reaction for the production of D-threonine, we use 7.2 to 7.5 pH. Temperature used was 25 degrees centigrade. RPM is 200. Duration 0 to 20 hours. Weight cells, we use permeabilized weight cells, 20 milligram per ml. These weight cells were permeabilized by freeze and thaw method. Reaction components, volume, final concentration. Water 229 ml, buffer, none. Glycine 2 molar, 250 ml. acetaldehyde is 5 molar, is continuous feeding, 10 ml per hour feed for 0 to 12 hours, then reduced to 5 ml per hour feed, 12 to 20 hours. PLP 100 millimolar 1 ml, manganese chloride 50 millimolar 10 ml, sodium sulfide 664 milligram, beta mercaptophenol 1 molar 10 ml, and FMDTA weight cells 10 gram for 500 ml reaction, and final concentration can be viewed from the right hand side. Likewise, glycine final concentration is 100 millimolar, PLP final concentration 0.2 millimolar, manganese chloride final concentration 1 millimolar, sodium sulfide 10 millimolar, BME 20 millimolar, weight cells 20 milligram per ml. After the reaction during the reaction for 20 hours, sampling is done at each one time point. Then Maffei's reaction is done. For Maffei's reaction, 1 ml sampling was done during the reaction at each time point and was diluted 100 times with HPLC water. D-Threonine standards 0.005%, 0.01%, and 0.02% were prepared, and mappage reaction was performed. Like this, sodium bicarbonate 1 molar 18 microliter, standard and our sample 12 microliter, DMSO 50 microliter, mappage reagent 20 microliter. These were mixed and vortexed well and kept at 40 degrees centigrade for 2 hours. Then it was cooled to room temperature by keeping 2 minutes at 20 degrees centigrade, and the reaction was terminated by adding 20 microliter of 1N HCl. Then reverse phase HPLC was performed. For HPLC, mobile phase was 30% methanol with 0.1% trifluoroacetic acid, TFA. It was in isochatic mode, 0.8 ml per minute flow. Column temperature was 35 degrees centigrade, run for 50 minutes, and column was C18 column. Results can be assessed like this. First, calibration curve for D-Threonine was prepared. These are the results like 0 mg per dl area 0, 5 mg, this is area 10 mg and 20 mg per deciliter. Area was determined from HPLC peak for D-Threonine, and D-Threonine histogram graph was plotted like this. ppm on the right hand side, on the x-axis, on the x-axis was plotted against area on the y-axis. And D-Threonine production was assessed. This is the curve for D-Threonine, and it is plateau at 33 gram per liter. Likewise, glycine content was also assessed. It was starting point was 70 gram per liter around, and it decreased continuously up to 20 hours. It decreased, and D-Threonine is we can say it's a reaction byproduct. In this reaction, it was in very minimum concentration, and it was assessed also throughout the reaction.